Support me. Hi guys, welcome to High Entropy, day 84 of DSA learning. So, if you are watching for the first time, so I just wanted to let you know that what I'm doing. Actually, I'm solving the DSA problem, and I'm following a course from Take You Forward by Striver. So it's day 84th of DSA learning, and my goal is like every day solve at least one problem. As you can see, my streak is 86 days, and so far I completed uh, you can say binary search, array, and what else, array, binary search, and now I'm solving the dynamic programming problem, DP problem, most important one. So if you see there is a DSA playlist. So I'm not sure if it is for, let me see it. I think it's for everyone. It's open. Let's see. Okay. So okay, sorry. Actually, I'm not sharing my screen. I hope. Let me transition it. Now you can see it. So here you can see DSA playlist, and you can watch videos, and I mean you can follow it if you wanted. And after that, I will jump into. So right now I'm solving the DP problem. Here you can see I'm just logged out. Oh, no. This is not what I'm expecting. Where is that? Yeah, here you can see it's logged out. I'm logged out, and you can see. So here dynamic programming problems. I hope it will be visible to everyone. Come on, man. Seems like it's slow. Continue without login. I think it will work. Rath Yatra offer live now. Okay. What is this offer? So DP on right now I'm solving the DP on MC. Oh god, I clicked it and it's DP on MCM, matrix chain multiplication. So I solved two problems. I think you can solve it directly here. I don't think they will give it, like if you wanted to use their platform definitely, because they are paying also. So of course they will charge you. Uh, because they are not like big companies like Google or something, so that they can give it for free, especially when you are running the code. So it's better you can run it locally, or maybe use lead code for solving it. But yeah, you can read the problem definitely. For example, it's now third burst balloon. I have to solve it. Seems like it's slow as well. Maybe it's incognito mode. Could be. Don't know. So okay, let's solve it here in the logged in section. Okay, so let's target today's problem. Burst balloon. Solve. So we need to check. So given n balloons indexed from 0 to n minus 1, 0 to n minus 1, each balloon is painted with a number, okay, on it represents by an array num, represents by array nums. Okay, burst all the balloons. Okay. If the ith balloon is burst, the coin obtained are 1 minute, bro. So if the ith balloon is burst, the coins obtained are nums of I minus 1 previous balloon into nums of I current balloon and I plus 1. So basically you are going to multiply all the adjacent balloon and existing current balloon, or coins that can be collected by busting the balloons wisely. Okay, if the balloon is burst, the coins obtained. If I minus 1 or I plus 1 goes out of bounds, out of uh, out of bounds of the array, treat it as if there is a balloon with a one painted on it. Okay, okay, got it. Hmm. Let's what needs to be done. First thing is function. I will use function. So we have given n balloons. I don't know who n. Okay, so we have given n balloons. The balloons spelling is correct or not? I feel like it's not correct. Bro, it's correct only. I have confusion. And our goal is maximize uh, coins. Balloons are like 0 to n minus 1. You can say 0 to n minus 1. And here array of I or ith balloon basically is if you are bursting that balloon, so it will generate basically the coins that you learn is array of I minus 1 previous one into array of I plus 1, and you have to sum up all the, so you have to burst all the balloons. That is one thing. So one thing here, so definitely every time we have choices whether we want to burst that balloon or not. So like there are 0 to n minus 1. These are the different balloons you can say, and we are going to pick a balloon, let's say k. You are picking a kth balloon, so k minus 1 you can say. You are picking any out of these balloons and you will burst it, and then what you will do, so then you will basically you are going to say, okay, I busted this balloon. Now you have to tell me the cost coins you can get from here and you can get from here. I think I misunderstood about. Suppose you are busting, if you are busting all the balloons and you are getting the cost, I is nothing but array of I minus 1 into array of I plus 1 and array of I. Then how it is going to, if we are going to burst all the balloons, then definitely it depends on what. In this way, if I'm bursting any balloons, 358, 351, 3158, let's say these are the balloons, coins. So you can burst anyone. 315, 3, treat is 3158. I think I need to see the example first. 3158. Okay. So what? 358. So basically, they burst the first balloon. So cost will be 315. Okay, it's not like you bust, but you still get the con. Okay, that means if you are three, you are burst. First, you burst this one. So now only the remaining balloons are 3, 5, and 8. So out of these, you can pick anyone and you can burst. So 3, you pick 5. So you got 5 into 3 into 8. Now you have only 3 and 8. So you will pick 8 and you will burst it. So once you will burst it, then it will be like 8, 3. I think you first burst what? No, 138. Okay, 138. So you burst the 1 and 3. Basically you burst 3. So 138, and then 1 into 8 into 1. So okay, this is the process. So out of these, whatever balloon you are choosing, remaining will be part of it. So let's say you choose this balloon first, then only after it remaining will be 3, 1, 8. Out of that you need to uh, check. Now you choose, imagine you choose 8, so you pick 8. Now only will be remaining 3, 1. Now you choose 3, so only remaining will be 1, 1, 0, empty. Okay, so can I? No. So every time we burst a balloon, so how many times we are bursting? I mean 1, 2, 3, 4. So number of balloons, number of burst. So every time we burst a balloon, basically you can say neighbor will change. For example, earlier it was neighbor, now 3, 1, 8 is the neighbor. It's like 0, 1, 2, 3. Earlier we have this. How to use matrix chain multiplication here? Definitely we need to check out of these. So at starting we have I equals to 0, j equals to n minus 1, and out of these you will say okay, I will choose one. So k, for k in 0 to n minus 1. Perfect. You select one, and when you are selecting, then what is the criteria? Suppose you selected k, kth. That means we have only 0, 1, 3, but but how would I know the one I picked? We need to have to remove it, right? If we are trying that option. So we'll say, let's say k equals to 2. You choose 2. Now you have k equals to 2, this index. So you will not consider it anymore. You burst the balloon. 0, 1, 8, and 0 and 1 and 8. 0 to 1. Okay, no, 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 it won't work. Some sort of strategy I need to use. So if I'll do one thing, 3 1, and here I have 8. Okay, now the thing is, when I'm calculating 8 for 8, definitely it should be 8 and 1, and here whatever is remaining. So it's very important. It should be part of the last one, whatever you choose. And here we'll be having 1. Okay, and 3 and 1. So for 3 and 1, you have two options. If you are taking 3, that means you will be having here blank, here 1. And when it comes to compare for 1, so what are the neighbors of it? If you took 3, then its neighbor will be only 1. Okay, oh, it's confusing. I mean, yeah, no, it's not gonna help me. I'm just getting into worse with worst solution. Somewhere something is missing. Let me try another time. 5 8 3158. What is the example? 3158. So why don't I transform it to 1 3 1 5 8 1? So this is our array. I will point here, J will point here. Perfect. But how? Now you will choose K between I and J. Let's say you choose K as this. K. Imagine, okay, I took the K. Now, okay, now if I'm busting 3, so if you are busting, I'm busting 3 first, then what is the solution for 3? For 3, it will be 1 into 3 into, it should logically be 5. If I'm busting 5, then it should be somewhere 3, 5, 8. It should be like 3, 5, 8. So for a 5, I mean, yeah, 8 will work, but what about 3? No. So logically, what should be there when we are splitting it at k? So k. So it should be something like 1, 3. So 3 is only remaining I and j. Okay, and there should be 5. And when it comes to this one, this block, it should be somewhere 8, 5, 1, and 3. But I and j point to this I and j. No, 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 it's not gonna be something. Time. How much time I just wasting time or what? 23 minutes. Fuck, bro. And choose k between I and j. It looks complicated for me. Complicated to me. But I don't know what's wrong. I'm not able to get. I'm not getting intuition behind it. What exactly? How we are going to split it? When I'm splitting somewhere, when I'm choosing k, there is a dependency on k, and it decides. Suppose you choose k, so remaining element. It's like you have to find. And remaining part, if we need to calculate, then it's like you are just removing this. 13581. Okay, if I'll choose this, any particular I'm choosing, then based on that 13581. So 3 will be there. It should be something like 35811. But how to discard one? If I'm using like here I to k minus 1 and k plus 1 to j. 31581. 131581. Okay, now if I will to take this, that should be I discarded. Now logically it should be 13581. But how to calculate it? I mean, how to discard it? If I'll split it into two parts, then it could be 3, 1 be one part, 5, 8, 1. Now, which one to choose? Logically, it should be like you are choosing again from these three, and here are the maximum coins that can be collected by bursting the balloons wisely. Oh god, I'm not able to get intuition. No, bro, not This is not right approach to solve our approach. Return the maximum coin can be collected by busting the balloons. So what I'm missing somewhere, something is 13581. These are the elements we need to bust one and collect coin. That is okay. You can collect, you can choose out of these. But when you are choosing an element, let's say you choose this, then do we need to solve this part or separate this part or separate? And is it acceptable? No. I think problem is if you will do this, then it will be something like 1 3 5 and another one 5 3 5 8 1. So actual uh, items are these two, and this is pseudo that will help you to calculate. And here this is the actual one. Okay, no, this is not the fate. 1 13581. Now you have this corpus and you can search pick anyone. So I is equals to 1, j equals to not getting any logic bancho. क्या है? Timekeeper, 10 minutes. Think 131581. You pick one element, you pick an item out of it. Now that is no more part of it. So remaining you have to check what is this outcome. Okay, you pick an item or balloon. Now uh, solve for remaining. Looks good, but how to solve for remaining? Definitely, it's not like there are two parts. What I feel. I mean, yeah, it's the same array. Array has changed, but the only thing is like one element out of it is gone. It should be. It's like this now. Now, if I wanted to choose, there are options. I, this one, and this one. And now you are going to again select something. So, like if you are selecting this one, then can I say for this one array of I into array of I minus 1 into array of I minus 1 into array of I plus 1. Okay, this is one thing, but here if you see, this has already been concluded. So now if I'll take this, let's you took 3. So logically what happens, 3 is gone. So first you have 1. Now it's like it's more of like it's more it's kind of logically it should be something 1158. Okay, forget about those. Now you have two options only. Out of that you need to pick something. One three five eight five eight 58. अबे भैंसोद ये क्या आ गया बेकार फालतू completely off. I cannot create array every time array. Otherwise, it will be like you will end up with lot of storage because what you are doing, you are passing a new array to the. Okay, that won't be efficient. And let me see how many elements can be there. N can be 300. Nums of I can be between 1 and 100. I just got this intuition. Intuition for this, like okay, I need to add, but You always have multiple options. Always have option to choose, but I 3158. Our goal is to get maximum profit. So to get maximum profit, what we'll do, you will pick an element that can give you maximum first. Sort, no. If you'll sort 1358, but that is not the relative order, so yeah, it won't work. So okay, not getting intuition even.
Maybe another macro taking forward. Today we will be solving the problem burst balloons. Now what does the problem say? The problem state you're given n balloons. Like over here n is 4. So you're given 4 balloons. Every balloon has a number written on it. Like this first balloon has a number 3 written on it. The second balloon has a number 1 written on it. The third balloon has a number 5 written on it. And the fourth balloon has a number 8 written on it. Okay. So you have to burst 10. Imagine if I'm bursting 5, then the number of points that you will get will be the left side of it, he himself, and the right side of it. So it is 40 coins is what you will get if you burst out 5. 40 coins is what you'll get if you burst out 5. So the question states you have to burst the balloons in any order you wish. You can burst 5, then you can burst 8, then you can burst 1, then you can burst 3. Or you can go 3, then 5, then 8, then 1. You can follow any order. And in following the order, you will be getting some points. Because every time you burst a balloon, you get some points. So the summation of the coins, the summation of those coins should be maximum is the question. For an example, if I decide that the first balloon that I'll burst is 3, then what will be the number of coins that it will be adding? The left of 3 is 1, right of 3 is 1, and he himself is 3. So the number of coins added will be 3. Okay, after bursting this, you're left with 1, 5, and 8. Imagine I say, hey listen, can you please burst out 1? Can you please burst 1? Now remember, previously 1 had a 3 on the left, but since you bursted that balloon out, for this one there is no 1 on the left, there is no 1 on the left. So since there is no 1, you take 1, you take 1 itself, and on the right it is a 5, so you take 5. So the total will be 5. Now I decide after this you have 5, 8. Now I'm deciding that, hey listen, let's burst out 5. So we're bursting out 5, you'll get 1 on the left, 5 himself, and 8 on the right. 1 on the left, 5 itself, 8 on the right. So I guess this will be 40. Right after this, you'll be left out with 8. So if you're left out with 8, the left has nothing. If you're bursting 8, he himself, and the right has nothing, which is this. So if you add this up, I think you will get 56. So the total number of coins that you get if you are bursting out first 3, then 1, then 5, then 8, the total number of coins that you'll get is 56. So the order that we took was very simple. First 3, then 1, then 5, then 8. What if I say, at first, let's try bursting out 1. At first, let's try bursting out 1. So if I try bursting out 1, it will be giving me 3 on the left, 1 himself, and 5 on the right, which is a summation of 15. Right after this, we will have 3, 5, 8. Right? So after this, what I'll do is, I'll try to burst out 5. So I burst out 5, 5 himself. On the left, we have a 3. On the right, we have a 8. So the summation total will be 120. Right after this, we have a 3, 8. Now I decide that, hey, listen, I'm going to burst out 3. So if I'm bursting out 3, 1 on the left, 3 himself, and 8, which gives me 24. Right after this, I have 8, which means 1 on the left, 8 himself, 1 on the right, which is 8. So if I summarize this entire stuff, you get 120 plus something like that, you get 167. Yeah, if you summarize this up, you have to maximize it. So 167 is the maximum points that you can get if you follow the order of at first 1, 5, 3, 8. Like if you follow 1, 5, if you're following 1, 5, 3, 8, the maximum points that you'll get is 167. You can follow various other ways, but you will see that 167 is the maximum that you can obtain, right? So pretty much that is the question. So how do you solve this question, or how do you approach this question? Now, again, write down the example. It was very straightforward. 3, 1, 5, 8. So you see a pattern to this question, because is this somewhere related to the partition or the MCM question that we did? By the way, if you have not seen the MCM DP and the previous DP50, I'll recommend you to watch both these, because if you're not watching those both couple of videos, you'll not understand this. Okay, so please go back and watch out the MCM video as well as the DP50 and come back and watch this. Okay, so you have to follow an order, right? Like you can follow 3, then 1, then 5, then 8. You can follow an order like 1, then a 3, then a 5, then an 8. You can follow an order of 8, then a 1, then a 3, then a 5. So they can always be various set of orders. But you need to understand which will be the first you pick. So apparently this is the entire range of elements, right? Like 3, 1, 5, 8. Anyone among them can be the first. 3, 1, 5, 8. Anyone can be the first. Like you can burst out 3, you can burst out 1, you can burst out 5, you can burst out 8, you can burst out anyone. Okay. So can I say the range is this? Like if I take this is the starting point, this is the ending point. In between them, including 3 and 8 or 1 or 5, anyone can be a first element. Makes sense? So I can think it in the direction of MCM, because in the MCM, if you remember, there were matrices like A, B, C, D. Then we decided that we'll first take B and C, multiply. Then the resultant goes and gets multiplied with these couple of guys. That is what we did. So can I similarly say, if I consider this as an entire star, you decide which one is the first element. It can be 3, it can be 1, it can be 5, it can be 8. Then we start thinking of the second element. Then we start thinking of the third element. So we can follow the topic. But can be. So let's understand can be or can be not by taking a simple example of B1, B2. Like I'm just not taking numbers. I'm randomly writing balloons. Okay. So it's like balloon 1 has this value, balloon 2 has this value, balloon 3 has this value, balloon 4 has this value, and so on. So imagine, I say you, okay, hey listen, let's burst this down. That is B4. If I'm bursting B4, what is the value that I add up to the answer? Can I say B3 into B4 into B5 is the points that I'll get? Like B4 himself, B3 on the left and B5 on the right. Is this the value that we will get? Definitely. So I will be left with this subportion to solve. Right? So I'll be left with a subportion of B2, B3. This is a subproblem. I can call it as a subproblem. This subproblem has to be solved. And I'll also be left out with another subproblem of B5, B6. So apparently, can I say this? Can I say this? What is? This is a value plus this subproblem be solved plus this subproblem be solved. Can I see this? The answer to this is no, I cannot. I cannot see this. Like I cannot just burst B4 and then solve this individually and then solve this individually, add up this answer. Will that work? The answer to this is no. Why will that not work? Let's understand. So I'll just erase this. I hope you got it. If I burst B4 at first, what will happen? Why solving them independently will not work is the main concept of this problem. So why this problem and this problem cannot be solved independently is the main concept of this problem. You understand that? You are pretty much true. So imagine if you're bursting out B4, this over, right? And what is the state? Like if you imagine the state, what is the state? The state after this will be B1, B2, B3, B5, B6, right? So just imagine if you would have taken this as an individual subset, if you would have taken this as an individual subproblem, and you would have bursted out B3. Apparently, right after this, right after B4, you would have decided to burst out B3. Who would have been the right guy of B3, B5? So can I say, even if I take this subproblem independently, this B3 depends, like B3 will be taking a dependency of B5, right? Or if I say, after B4, I decide to burst out B5, then also, like if I burst out B5, then right on the parallel, it has a B3 dependency and it has a B6 dependency. So imagine if you're bursting out B5, after this you will have B1, B2, B3, B6. So after this, if you decide to burst out B6, this B6 still has a dependency on B3. So you cannot just randomly decide that this is an individual subproblem. Because for BP to work, this has to be an individual subproblem. You should not be depending on the values of this. Understood? And you might argue, but Striver, if B6 is getting bursted, we just take the B3 as the left guy. No, that will not work. Imagine after bursting B5, you had B1, B2, B3 and B6 and you decided to burst out B3. So this B3 was dependent not on B5, rather on B6. So depending on who is getting bursted, B3 might be dependent on B5, B3 might be dependent on B6. So you cannot individually solve these couple of problems. You need to understand, you cannot individually solve these problems. You absolutely cannot. So the key point to notice is, if I start from the front, like we basically go across this, like I just take you over here. We first had 1, then we had 5, then we had 3, then we had 8. So you cannot go in this direction. Instead of this, I will say, why can't I go in the opposite direction? You'll start thinking in the opposite direction, Like I will say, if there are 4 elements, who was the last guy? And the answer that I'll get is 8. And the answer that I'll get is 8. Then I'll say, who's the second last guy? And if this is a problem, I get this is the second last guy. After that, I'll say, who is the other guy? So it says 5. After that, I'll ask who's the other guy. I'll say this. Let's realize. Let's take this example only and understand. Okay? 3, 1, 5. So 3, 1, 5, 8. Okay? I say, like, 8 is the last guy to be bursted. Okay? So as of now, we have this entire range. That has to be solved. Now, to avoid complications, we know on the right of 8 there is no 1. We know on the left of 3 there is no 1. So what I'll do is, just to avoid complications, I'll add a 1 and I'll remove this. And I'll also add a 1 over on the right and I'll remove this. But these are the numbers that I have to solve. Just to avoid complications, I added a 1 and then a 3. Now imagine this is the last guy to be solved. And initially this is the range that you're looking at. And I'm saying, instead of now on this range deciding which is the first guy, I decide who is the last guy. So if I decide who is the last guy, can I say the cost will be 1 into 8 into 1 if 8 is the last guy. Just imagine if 8 is the last guy. Can I say the cost will be 1 into 8 into 1, which is, if this is the range, the left of the range, right of the range, and the number itself. So decided 8 is the last guy. So this is the point that will be added. Just going in the reverse way. Okay. Right before this, if 8 is the last guy to be bursted, right before this, if you remember, there was 3 and 8, or what was it? Let's go back and watch 3 and 8. So 3 and 8 was the guy, and I decided to burst out 3. So if 3 and 8, realize, if 3, 8 and 8 is remaining, that means you've bursted out 8, and you just have this much range. So this erase out. You're going from the back, so you just have this much range. This has been bursted. Last. So now I'm saying you have a 3 that has to be bursted. You have a 3 that has to be bursted. So can I say for this 3, I definitely know, since I've bursted out before 8, 8 will be the right guy to it. Because I'm going in the reverse direction. Just because 8 was here, in the next step I was able to burst 8. So I'm very much sure that 3 has the right guy 8 because all the others would have been bursted in these steps. Like 1 would have been bursted here, 5 would have been bursted here. So 3 been bursted, sure. You can definitely know 3. You're going from the back, so you just have this much range. This has been bursted. Last. So now I'm saying you have a 3 that has to be bursted. You have a 3 that has to be bursted. So can I say for this 3, I definitely know, since I've bursted out before 8, 8 will be the right guy to it. Because I'm going in the reverse direction. Just because 8 was here, in the next step I was able to burst 8. So I'm very much sure that 3 has the right guy 8 because all the others would have been bursted in these steps. Like 1 would have been bursted here, 5 would have been bursted here. That's 8. So I'm very much, just because 8 was here, in the next step I was able to burst 8. So I'm very much sure that 3 has the right guy 8 because all the others would have been bursted in these steps. Like 1 would have been bursted here, 5 would have been bursted here. So 3 definitely has the right guy as 8, which is, again, 3 itself. This is the range. This is the range. On the left of range is 8, on the right of range is 8. So 1 into 8. On the left of is 1, on the right is 8. Perfect. So you bursted out 3. You burst out 3, what are you left with? And I say this is the range that you're left with. And in this previous, if you go across and you see you're just having 3, 5, 8, and in this you decide to burst out 5. Yes, in this you decide to burst out 5. Again, if you're deciding to burst out 5, you're definitely sure this is the range, right? And 5's right is 8, 5's this guy is 3. So you say 5 on the right is 8, and on this range on the left is 3. Again, why does this work? Because you know this guy will be bursted over here, right? So anyone who is not in the range would have been bursted in the next counter. Will be bursted in the next counter. So he exists over here. He exists over here. Since you're going in the opposite, you definitely know 3 and 8 exist because you're moving in the opposite fashion. So 3 and 8. Perfect. Now you go back. And when you go back, you would have bursted 5. So the remaining range will be just 1. The remaining range will be just 1. In order to burst 1, then you look on the left, which is 3, 1 itself, and on the right, which is 5. And you get a 15, you get a 120, you get a 24, you get an 8. Just move in the opposite direction. You just move in the opposite direction. And if you move in the opposite direction,
Not getting
the
bro.
sub-problems will be independent. Like let us take one. So what I'll do is just to avoid complications, I'll add a 1, and I'll remove this. And I'll also add a 1 over on the right, I'll remove this. But these are the numbers that I have to solve. Just to avoid complications, I added a 1, I added a 1 on the left hand. Now imagine this is the last guy to be solved. And initially this is the range that you're looking.
Last
I'm
guy.
saying, instead of now, on this range deciding which is the first guy, I decide who is the last guy. So if I decide who is the last guy, can I say the cost will be 1 into 8 into 1 if 8 is the last guy. Just imagine if 8 is the last guy. Can I say the cost will be 1 into 8 into 1, which is if this is the range, the left of the range, the right of the range, and the number itself. So I've decided 8 is the last guy. So this is the point that will be added. I'm just going in the reverse way. Okay. Right before this, if 8 is the last guy to be bursted, right before this, if you remember, there was 3 and 8, or what was it? Let's go back and watch 3 and 8. Yeah. So 3 and 8 was the guy, and I decided to burst out 3. So 3 and 8, realize if 3, 8, and 8 is remaining, that means you've bursted out 8, and you just have this much range. So this is erased out. You're going from the back, so you just have this much range. This has been bursted. Last. So now I'm saying you have a 3 that has to be bursted. You have a 3 that has to be bursted. So can I say for this 3, I definitely know, since I've bursted out before 8, 8 will be the right guy to it. Because I'm going in the reverse direction. Just because 8 was here, in the next step I was able to burst 8. So I'm very much sure that 3 has the right guy 8 because all the others would have been bursted in these steps. Like 1 would have been bursted here, 5 would have been bursted here. So 3 definitely has the right guy as 8, which is, again, 3 itself. This is the range. This is the range. On the left of range is 8, on the right of range is 8. So 1 into 8. On the left of is 1, on the right is 8. Perfect. So you bursted out 3. You burst out 3, what are you left with? Can I say this is the range that you're left with? And in this previous, if you go across and you see you're just having 3, 5, 8, and in this you decide to burst out 5. Yes, in this you decide to burst out 5. Again, if you're deciding to burst out 5, you're definitely sure this is the range, right? And 5's right is 8, 5's this guy is 3. So you say 5 on the right is 8, and on this range on the left is 3. Again, why does this work? Because you know this guy will be bursted over here, right? So anyone who is not in the range would have been bursted in the next counter. Will be bursted in the next counter. So he exists over here. He exists over here. Since you're going in the opposite, you definitely know 3 and 8 exists because you're moving in the opposite fashion. So 3 and 8. Perfect. Now you go back. And when you go back, you would have bursted 5. So the remaining range will be just 1. The remaining range will be just 1. In order to burst 1, then you look on the left, which is 3, 1 itself, and on the right, which is 5. And you get a 15, you get a 120, you get a 24, you get an 8. Just move in the opposite direction. You just move in the opposite.
3158. So imagine first what we are doing, we bust 8. So if I'll bust 8, then it will be something like 8 into 1 into 1 into 8. Now the next element that we bust, let's say it's out of these any elements. Okay, now it could be let's say it was 1 before, so before it, so 1, so you bust 1, then you bust 8. Now it could be Okay, these are the two elements. So it could be the order was 8 into 8 1 or 1 8. So that does not matter. The important is one of neighbor, it would be 1. One of neighbor will be 8, and another one will be depends on conditions. So right now what will be? It is like 1 and 8, let's say. Now you choose 3. After 3 you choose 3. So when you bust 3, so 3 can be here, or 3 can be here, or 3 can be here as well, right? Imagine 3 is here, then it should be cost will be 3 into 1. What is time right now, bro? 9:25. I was expecting like I will finish it before. God. 3 into 1 into. Oh, there are plenty of options, bro. I mean, uh, okay, let me think again. At starting, you have 8 only. So 1 into 1, 8 into 1. You got. Now you got when you picked, like, okay, maybe you busted before 8, you busted 1. So when you busted 1, then it will be like something like here, 1 will be part of it. So either it could be here 1 and 8 like this, or it could be 8 and 1, but that does not matter. No, okay. No, I think we need to maintain the order in which we are doing it. So here it will be something like you are doing then 1 into 8 into 1. Okay, now use just I said like okay, let me take 3. So it should be something like 3 1 8. So 318. Now we have numbers 318. So 318, that means 3 1 into 3 into 1 will be the cost of bursting it. And now you will say let me take 5. So it will be something 3 1 5 8. And here the cost of bursting 5, 1 into 8, 5 into 1 into 8. Okay.
opposite direction. And if you move in the opposite direction, write the 8 because all the others would have been burst that, and I decided to burst out 3. So 3 and 8 realize just to about complication, I added a 1 on the left hand. Now imagine this is the last scalar to be solved, and initially this is the range that you're looking at. And I'm saying instead of now on this range deciding which is the first scalar, I decide who is the last scalar. So if I decide who is the last scalar, can I say the cost will be 1 into 8 into 1 if 8 is the last scalar. Just imagine if 8 is the last scalar. Can I say the cost will be 1 into 8 into 1, which is if this is the range, the left of the range, right of the range, and the number itself. So I've decided 8 is the last scalar. So this is the point that will be added. I'm just going in the reverse way. Okay. Right before this, if 8 is the last scalar to be bursted, right before this, if you remember, there was 3 and 8, or what was it? Let's go back and watch 3 and 8 here. So 3 and 8 was the guy, and I decided to burst out 3. So 3 and 8, realize if 3, 8, and 8 is remaining, that means you've bursted out 8, and you just have this much range. So this erase out. You're going from the back, so you just have this much range. This has been bursted. Last. So now I'm saying you have a 3 that has to be bursted. You have a 3 that has to be bursted. So can I say for this 3, I definitely know, since I've bursted out before 8, 8 will be the right guy to it. Because I'm going in the reverse direction. Just because 8 was here, in the next step I was able to burst 8. So I'm very much sure that 3 has the right guy 8 because all the others would have been bursted and these steps, like 1 would have been bursted here, 5 would have been bursted here. So 3 definitely has the right guy as 8, which is, again, 3 itself.
Right guy. Oh, based on the table order? I mean array order.
On the left of range is 8, on the right of range is 8. So 1 into 8. On the left of is 1, on the right is 8. Okay. So you bursted out 3. You burst out 3, what are you left with? And I say this is the range that you're left with. And in this previous, if you go across and you see you're just having 3, 5, 8, and in this you decide to burst out 5. Yes, in this you decide to burst out 5. Again, if you're deciding to burst out 5, you're definitely sure this is the range, right? And 5's right is 8, 5's this guy is 3. So you say 5 on the right is 8, and on this range on the left is 3. Again, why does this work? Because you know this guy will be bursted over here, right? So what's 8, and on this range that is 3, right? And 5's right is 8. 5, yes, in this you decide to burst out 5. Again, if you're deciding to burst out 5, you're definitely sure this is the range, right? And 5's right is 8. 5, yes, in 5, you go across and you see you're just having 3, 5, 8, and in this you decide to burst out 5. Yes, in this you decide to burst out 5. Again, if you're deciding to burst out 5, you're definitely sure this is the range, right? And 5's right is 8, 5's this guy is 3. So you say 5 on the right is 8, and on this range on the left is 3. Again, why does this work? Because you know this guy will be bursted over here, right? So anyone who is not in the range would have been bursted in the next counter. Will be bursted in the next counter. So he exists over here. He exists over here. Since you're going in the opposite, you definitely know 3 and 8 exist because you're moving in the opposite fashion. So 3 and 8. Perfect. Now you go back. Now when you go back, you would have bursted 5. So the remaining range will be just 1. The remaining range will be just 1. In order to burst 1, again you look on the left, which is 3, 1 itself, and on the right, which is 5. And you get a 15, you get a 120, you get a 24, you get 8. Just move in the opposite direction. You just move in the opposite direction. And if you move in the opposite direction, the sub-problems will be independent. Like if I just take one more example of B1, B2, B3, B4, B5, and B6, right? So if I'm taking this example, if I just decide that, hey, listen, I am going to burst out, for example, B5. If I'm deciding to burst out B5 out of this range, then what I'll do is, if this is I, this is J, I know the left guy of this is A of I minus 1. I know the guy itself, imagine this is index, is A of index. Imagine the right guy is J plus 1. This is the point that you will get if this guy is bursted right at the end. And this is a subproblem that has to be solved. This is a subproblem that has to be solved. So you will say, can you please solve the subproblem from here to here, which is I comma index minus 1? Because if this is index minus 1. And if this is index plus 1 to j. So these are the two subproblems which you can easily solve. Now, are these subproblems independent is my question. Are these subproblems independent is my question. Obviously, they are independent. Yes, they are independent. Let me give you a proof. Are they independent or not? But B1, B2, B3, B4, B5, and B6, okay, I've taken this. Now imagine I'm saying B4 is the last guy to be executed, bursted rather. So B4, you're definitely sure the answer is 1 into B4 into 1, right? Right before the step, what will be the step? This is a subproblem, as I said, that you have to solve, or this is a subproblem. Right? As I know, B4 was the last guy to be bursted. I definitely know, B4 will exist over here, because only if B4 exists, then only the next step will get bursted. I repeat, B4 has to exist in the second last burst, and this is the last burst. B4 has to exist, because if B4 exists in the last burst, then only it can get bursted, right? So this is a problem that you're solving. So can I say, since this is lying over here and B4 exists, B4 will definitely be the guy who is on it, yes? And can I say, probably, it can be B1, B4 in the last step, probably, or it can be B2, B4 in the second last step, or it can be B3, B4 in the second last step, or B4, B5, or B4, B6. It can be either this or this or this or this or this, anyone. No matter who is, what is, I am not dependent on these guys. Instead of that, for B5 or for B6, I'm just dependent on B4, who is the guy to the left of it. I'm not dependent on this subproblem. Carefully see, sir, proof that it is not dependent on the left subproblem. Even if you're solving for B1, it's dependent on the range right guy, not on anyone over here. That is the proof. So I have easily proved you how this formula comes up. Again, I've given you why. Just the trick is there. You have to start from the bottom instead of the front. Instead from the front. I must be thinking, but how will we think that we have to think from the bottom? Again, this will come with practice. When I did this problem at the first instance, it did not strike me. I had to go through a lot of blogs, forums. Then I understood that they're actually starting from the bottom, and then I realized that this is how we need to solve it. Okay, so not an issue if you're not getting the solution right at the go, and you have to watch this video. Okay, so B1, B2, B3, B4, B5. Now, as I said, the first thing that you'll do is 1 and 1. So these are 5 balloons. Definitely n will be 5 balloons. And if I write them the next, it will be 0, 1, 2, 3, 4, 5. So can I say if n is 5, the first range that you're looking to solve, the first range that you'll be looking to solve will be f of 1, 5. Or this is the range that you're looking to solve. This is the subproblem that you're looking to solve, right? Now, in this range, like if B1, B2, B3, B4 is a range, and if I added 1 and 1, and this is the range, can I say this is I, this is J? Who can be the last guy if you're thinking in the last step? This guy can be your last guy. This guy can be your last guy. This guy can be your last guy. Or this guy can be your last guy. Anyone can be your last guy. And if anyone can be your last guy, can I say then it's very simple to write the recursion, and it's very simple. So since anyone can be the last guy, what I'll do is I'll just write the F, and I know this will be I and this will be the J. So this is the subproblem that I'm solving. So I've been given this, I'll try to solve it. Okay. And remember one thing: when we stop, even if we are having I and J over here, and this is a single subproblem, you still solve. You still solve it. So if you're taking B2, then J will be moving here. So the subproblem will reduce. If there is a subproblem, you will solve. But if there is no subproblem, then you stop. Like if at any moment I crosses J, if at any moment like you're just shrinking like this, and at any moment you've shrinked it enough so that there is no more subproblem. The least subproblem would be I equal to J, where you're solving a single. But beyond this, there will be no subproblem. If there is no subproblem, the coins that you'll get will be 0. If there is no subproblem, the coins that you'll get will be 0. Now, can I say this can be the first guy, this can be the last guy, last, anyway. So can I actually run a loop? Something like index will start from I and go till J. I can. So if you remember, the cost that we encountered was
Not getting bro. Fuck man, choke. Okay. So to be honest, I'm not getting the solution exactly how it is working. I mean, I need to watch more videos. Let me do one thing. I will rewatch the video. First, let me. Actually, I'm going out. It's not helping. So I'll do something like solution. I will submit it quickly so that my streak won't break. Really? Oh man, what you did, bro? Just want logic. I can build it tabulation or anything. I'll do it, but right now I'm not getting it.